You ever stop to think about how the batteries in, well, everything, our phones, our laptops, our cars, are actually made? We always hear about the fancy new chemistry inside, right? But what if I told you a massive leap forward was hiding in a step that's so small, so precise, you literally can't even see it? Okay, let's get into it. Yeah, you heard that right. We are talking about the simple act of cutting battery materials. And it turns out, getting this one tiny step perfect can unlock more power, can speed up charging, and just make our batteries last way longer. It's a pretty amazing story of microscopic precision having a truly global impact. So here's what we're going to cover. We'll start with the huge challenge of just making batteries in the first place. Then we'll see how scientists are using lasers to get that perfect cut. We'll take a super close look at what that cut actually looks like, and then I'll reveal a surprisingly simple trick that makes the whole thing work so much better. And finally, we'll connect that tiny little cut to the performance you and I actually care about.
All right, first up, manufacturing. You know, it's one thing to discover some amazing new battery chemistry in a lab. That's awesome. But that's only half the battle. The real challenge, the part that decides if that cool new tech actually changes the world, is figuring out how to build millions upon millions of them, all with perfect quality. Because at the end of the day, we all want the same things from our batteries, don't we? We want our phones to last all day, maybe two. We want our EVs to charge in like 15 minutes, not an hour. And we want them to go for hundreds and hundreds of miles. And hitting those goals, it depends so much on how well we can actually build the things.
So, one of the most critical steps in the whole process is how you cut the electrode materials, the stuff that goes inside the battery. For a long time, the industry has used mechanical cutting. Think of it like a tiny, super sharp blade. But just like any blade, it gets dull, it wears out, it costs a ton of money to maintain. The alternative? Lasers. It's a non-contact process, so nothing wears down, and it has the potential for a way higher quality cut, but only if you get it just right.
And getting it right means you have to understand exactly what's happening when a crazy powerful beam of light slams into this really delicate battery material. It's like this intricate dance of heat and energy, and it all happens in a split second. And this right here, this is what we're aiming for. This is a microscopic view of a cut made by a laser.
It kind of looks like a tiny canyon, doesn't it?
Well, to figure out if this is a good cut, scientists are laser-focused, pun intended, on two key measurements. So the first one is called the kerf width. Just think of it as the trench itself, the part the laser literally vaporizes through the metal foil at the center of the electrode. The goal here is simple. Make that trench as narrow and as clean as you possibly can.
The second one is the top width. Now, this is the collateral damage. It's the area on the surface, the actual active material, that gets blasted away by the intense heat. You could think of it as a scorched earth zone around that trench. And you want to make this zone as small as possible, because every bit of that material that gets destroyed is valuable energy storage you've just lost.
Okay, so let's zoom in even closer. It turns out, depending on the laser's power and how fast you move it, you can get some wildly different results. The researchers who did this study actually identified 6 totally distinct outcomes, or as they call them, phenomena. If you use too little energy, you might just kind of scratch the surface. A little more, and you'll remove that top material, but you won't actually cut through the metal foil. Crank it up, and you start melting things. What you're really looking for is that Goldilocks zone, that sweet spot, proper cutting. But if you overdo it, you get excessive cutting, and that is messy and really bad for the battery.
And wow, you can really see the difference here. On the left, that's a proper cut. Look how clean and straight it is. The damage is minimal. But on the right, that's excessive cutting. The edges are all jagged, the trench is wide and irregular. This is exactly what you want to avoid, because it can seriously mess with the battery's performance and even its safety.
So the big question is, how do you guarantee you stay in that proper cutting zone? And even better, make the cut even cleaner? Well, this is where it gets really cool. The researchers found a simple but unbelievably effective trick. And it wasn't about changing the laser. It was about changing the material before you even cut it. What if, before you hit it with this super powerful laser, you just squeezed it really hard? This process is called calendaring, and it turned out to be the absolute key to the whole puzzle. This slide really gets to the core of the discovery. On the left, you've got the uncompressed material. It's kind of fluffy, with lots of empty space between the particles. So when the laser hits it, all that heat gets trapped and creates a big, messy explosion. But on the right, that's the compressed material. It's way denser,
All those particles are packed in tight.
And that density is the secret sauce. For one, because it's so dense, it's just physically harder for the laser to blast it away. But here's the really brilliant part. The tightly packed particles act like a perfect little heat sink. The energy from the laser spreads out super fast and efficiently instead of building up in one spot and causing damage. And the result? A much cleaner cut with way less of that scorched earth zone. In other words, less wasted material. And the results are just striking. This chart shows you exactly how much active material gets removed during the cut. You can see there is a huge, dramatic drop in material loss when the electrode is compressed first. You're not just getting a higher quality part, you're literally saving valuable material.
Okay, so a cleaner cut is awesome for manufacturing. It saves money, it's more efficient, we get it. But does it actually make for a better battery? Does it matter to you and me? Let's connect the dots.
First, we gotta understand how battery performance is measured. You've got specific capacity, which tells you how efficient the battery material is per gram. It's a measure of pure quality. But then there's areal capacity, and honestly, this is the one we really care about. It tells you how much power you can cram into a specific amount of space. This is the number that decides how long your phone lasts or how far your EV drives.
And here it is, the final payoff. Now, interestingly, the uncompressed electrodes had a slightly higher specific capacity, that material quality metric, probably because it was a little easier for ions to move around. But because the compressed electrodes were so much denser and lost way less material during the cutting, they could pack more power into the exact same space. Their areal capacity was higher. And that's the bottom line. The better manufacturing process led directly to a more power-dense battery. So let's zoom back out. What does all of this microscopic detail mean for the future of batteries? Well, it's a really powerful reminder of where true innovation often comes from. The researchers themselves sum it up perfectly here. They say that by compressing the electrodes, you just end up with more of the good stuff, the active material, in the final product, and that directly gives you higher energy density. It's such a simple, elegant solution.
And really, that's the biggest takeaway from all of this. The race for better batteries isn't just happening in chemistry labs with scientists mixing up exotic new elements. It's also happening on the factory floor, with engineers perfecting every single step of the process, right down to a single perfect microscopic cut.
It just goes to show that paying obsessive attention to the tiniest details can lead to absolutely massive breakthroughs. A better cut means a better battery. A better battery means a better electric car, a better power grid, and a more sustainable future for all of us. It really makes you wonder, doesn't it? What's the next tiny little innovation out there that we're overlooking that holds the key to the next big thing?